Hi, hello everyone. Hi to all my warriors out there. How are you all doing? With full of energy, with full of Josh. Are you all ready for the session? Yes, I really know that. So yes, this is Ameer, your physics educator at an academy, and what you all have to do, jaldi se jaldi, give me an amazing thumbs up, and do let me know that I am audible and visible to all my warriors in the classroom. Jaldi, jaldi, jaldi. Hi Ratu, hi Atati, hi Pardeep, hi Zakir, Himu, fine. Good to know that. And I think you all must be so excited because weekends are coming, Saturday, Sunday. I know that most of you might be having so many good plans, but don't forget to study also. ठीक है? Is it just Irados are difficult, but you have to spend some time so that you will be more and more comfortable with it. Right? Hi Pardeep, hi Pal, hi Atati, hi to every warriors in the classroom. And in today's session, which is the second lecture for the chapter of work power energy, we'll be discussing about some of the important topics such as conservative and non-conservative forces. Then we'll be talking about energy, which is such as kinetic energies, potential energies. Then we'll be discussing about how force and energies are related to each other. Work energy theorem. Arey baap re, bahut sara hai. So many things are there to learn. So I hope everyone is going to be there till the end of the session so that this amazing topic can be understood. Isn't it? So yes, I really know that. Whoever is seeing me for the very first time, myself Ameer, I have an experience of more than 3.5 years in the field of teaching JEE, NEET and board students. I'm a beta graduate from NIT Calicut. I mentored and taught many students and every one of them are doing so good in their life. This is the schedule for this particular month, and which means here we'll be having 2 more lectures for work power energy, and then we'll be having the mentee war. Okay, and it is going to be super awesome, as you all know. As you all know, this is the right time to start learning because exams are approaching very faster, isn't it? And I think this is the best time to you for every one of you to start learning, so you can be a part of an academy family and start learning with us. And whenever you are coming to make a subscription, if you want 10% of off, don't forget this code AMB10. Bhuliye mat. Okay, it is very important. Next, you know that so many top amazing educators are there in Unacademy Class 11th and 12th YouTube channel, right? So what you all have to do, you just have to click on that link which will take you to a Telegram channel from where you'll get updates of everything happening in this particular YouTube channel. Any new classes, any new teachers, right? Any new lectures coming on, everything will be available. And Bugs Bounty program, it is an amazing way for every one of you to grab some prizes. What you'll have to do, you just have to go to description, you'll find a form, fill in the form if you're finding any inappropriate content in the video uploaded by Unacademy. Bas. And you have to know that Unacademy Combat scholarship test is going on for class 11 students at 1 p.m. You can enroll right now so that if you can get a very good mark, you can learn with Unacademy for free. Isn't it an amazing way? Yes. How many of you know what is the Emerge program? The Emerge program is actually started so that everyone can survive and get a very good mark for the new exam pattern of CBSE, right? So we'll be having multiple choice live mock test so that you can practice yourself how the questions are going to be coming for the new board exams. And jaldi se jaldi you can enroll. It is completely free for all the subject. It is available. It starts from September 11th onward. The code which you have to use is AMB10 so that you can log in for free. Code is AMB10. One last thing, just give me 2 minutes. I'll explain why Unacademy subscription is so much important at this point of time. Why we all teachers tell you to be a part of Unacademy platform, even though all the lectures and teachers are available for free in YouTube? It's very simple because there in Unacademy platform, we educators teach with a proper schedule targeting JEE, NEET and the board exam, which means everything is going to be in proper order and you can track every topic that is learned and taught to you, which means the process of learning is going to be super simple. Aram se with a smile you can learn. And there are so many top educators which is available only on the Unacademy platform, and learning with them, talking with them and getting some advices from them can happen, which means there are live chat boxes, in class calling facilities are there. You can have a very good bonding with all the teachers. Then study materials will be given to you so that you don't have to roam around looking for books from to learn. Practice test and live test series will make you super confident and will bring out the best in you all. And for all these amazing features, you have to just go for plus subscription. For 12 month subscription, it will cost you 1,250 per month. And for 24 months, it will cost you 1,042 per month. When are you gonna come? Okay, I think you all are gonna come once I give you an happy news. What is it? The code is there, AMB referral code. Use kar le, get 10% of discount from the above mentioned prices. Wow. Okay, let me tell you again. Iconic subscription. There are so many features in Iconic subscription, such as a personal mentor, someone to help you related to your academic activities, such as how to make the schedule, what to study, how to study, and everything. Live doubt solving classes will help you clear your doubts and take away all your doubts. Okay, when we all teachers, when it comes like these are special live doubt solving classes for you. Then weekly reports will help you find out your performances and will also help you find out your weak topics. Understanding weak topics and improving those weak topics can only improve your actual marks, right? For all these Iconic subscription, for 12 months, it will cost you 2,333 per month. And for 24 months, it will cost you 2,000 per month. चाहिए ना आपको? आप सब लोगों को चाहिए ना? बिल्कुल सर, हमको चाहिए, क्या चाहिए आपको? 10% of discount तो ले ले, code ले ले, AMB10, use it as a referral code, okay? And it will give you 10% of discount from this price, whatever it is being already described. So when are you gonna come? This is the right time, I'm telling you, okay? Don't make it late, because if you start now, you can complete your entire schedule for this month, okay? For your exam, and you can get a very good score. That's it. Now it's time for study. Here we are with Ameer sir, the chapter work power energy and all my variables. If you all are ready, we can start with this amazing chapter of work power energy for today's class. Hi Miara, good evening. Yes, I am doing so good. Thank you so much for asking. Hey Baisa, hi Siddhant. Wala chapter nahi pad, koi baat nahi. You can learn with me. This is a simple chapter, but an important chapter too. Are you all ready? Show me some fire in the chat box. Everyone, show me some fire. Jaldi se jaldi. Jaldi se jaldi, with a dab, with so much of energy, with full of love. Show me some energy in the chat box. Show me some fire. Show me some smiling faces. We'll start the class right now. We are going to wait for nothing, because the chapter of work power energy is waiting for us. Yes, everyone is ready? Okay, very good, amazing. Here we go. Now, yesterday, let us have a very quick recap of whatever we have learned in yesterday's class. We started the chapter. We have learned what is work. What was the formula for the work done? If force is constant, F vector dot the S vector, which is expanded as Fs cos theta. Theta is the angle between force and displacement, isn't it? Yes. Then we have learned about work, positive work, negative work, and zero work done. Though work is a scalar quantity, what does this positive sign signifies? It signifies that if you are giving a positive work on the body, its energy increases. Negative work means its energy decreases, or it take away the energy from the body. Understood? Okay. Then after this positive and negative work done, then we have seen, right, how to find out the work from where? From the force displacement graph. How many of you do remember? From force displacement graph, how to find the work done? Very simple. If you can find the area under the graph, if area under the graph is found out, that will be exactly showing the work done. Then the last topic of yesterday's session was how to find the work done in the case of a variable force, which means if force keeps on changing its value, okay, at this moment if it is 1 Newton, next time it is 2 Newton, फिर हो गया 3 Newton, फिर हो गया 10 Newton. If it keeps on changing, integrate करना है F dot dx, बस इतना याद है ना सब लोगों को? I hope you do all remember these many things. If you do all remember, it's time for me to check. It's time for Ameer sir to check how many and how much you have learned yesterday's topic. Okay, shuru kare. Let's do some problems from yesterday's topic. Then we will start the fresh new topic for today's session. Jaldi se jaldi. Let me see how many of you are gonna give me the answer before me give the answer. So jaldi se jaldi shuru kar le. I'll be looking into the chat box after me completing the explanation here. So jaldi. Let's start. Okay. A force F xi cap plus 2yj cap, which means the force is given in I direction, which means x axis, and also in the y direction. If force is given in both directions, what can you talk about? The displacement ds. Displacement will be happening along x axis and also y axis. What did I say now? As there is force acting along x direction and y direction, the displacement will be the sum of displacement along x axis and y axis, because the body will be moving along x axis and y axis. Very important. Okay. Find out the work done by the force. Okay, we will do to move the particle from the point A to B. If you want to move the point from A to B, how much work is done? First, look into the equation for force. Bol de, is it a constant force or is it a variable force? First, you have to understand that. F is dependent upon x and y, x coordinate and y coordinate, which changes its values. If x and y changes, force changes. Force is a variable. So how will you find the work? Kaise karega work? Work is equal to integral of f dot ds vector, f vector dot ds vector. Yesterday we have learned, है ना? और क्या? बिल्कुल. So start substituting. Force का value xi cap plus 2yj cap. Done, done, done. Displacement is the sum of displacement along, it is the dot product dxi cap plus dyj cap. I think you all have understood why I have written dxi cap and dyj cap, which are the displacement along x-axis and y-axis. Okay, done, done, bilkul sir, bilkul. Okay, kar le. Now what you have to do? You just have to do the dot product. Okay, doing the dot product, only you multiply those values in the same direction. So x is being multiplied with dx. ठीक है? So integral of x dx plus then we have 2y dy. It is 2y dy. Okay, bus integrate kar le. And from where to where you have to integrate, bata. Who is going to tell me the points from where to where it has to be integrated? सोच ले अच्छे से, दिमाग से सोच ले. हाँ, we have to integrate from A to B. क्यों sir? क्यों? Because the particle is moving from the point A to B. बस इधर तक कोई गड़बड़ नहीं है ना? कोई गड़बड़ नहीं? बिल्कुल नहीं सर. x dx integral x square by 2 है ना? And apply the lower limit and the upper limit. X is changing from 1, है ना? 1 and final value is 0. So lower limit is 1, upper limit is 0. ठीक है? Plus 2y dy का integral. 2 is a constant. Y का y dy is y square by 2. 2 cancel and apply the limit. Y is changing its value from देख from 2 to 1. So 2 to 1. बस हो गया. मेरा काम तो हो गया. फिजिक्स का काम हो गया. What is left? Mathematics. कर ले, जल्दी से कर ले. Start applying the limit. X takes 0 first. So 0 square minus 1 square by 2. Plus 2 cancel. Y first take 1. Upper limit 1 square minus 2 square by 2. है ना? Okay, sorry, 2 is not there. 2 is being cancelled. I'm really sorry. This is minus 3. This is minus half. So minus 3.5 with the unit of joule. Done, done. Answer तो मिल गया. बस और कुछ नहीं है. मिल गया? How many of you have given me the answer? Let me see. कोई आंसर दे दिया? हाँ, पल तो दे दिया. म्यारा दे दिया है. And we have Devika, Shishir. Very good. Seems like I'm teaching in a batch where all are super interested in learning. है ना? बिल्कुल. Then Pal, everyone. Very good. Pardeep. Okay, very good. Sai, amazing. Before me, बहुत बढ़िया बात है. Okay, Shishir, it's 3.5 with a negative sign. Okay, very good. बढ़िया बात है. Now let's see how many of you are going to solve this question before me. Okay, the competition between Various and Ameer sir starts now. Let me see who is going to give me the answer before me. Jaldi se jaldi, तुरंत से तुरंत. A particle moves along the x-axis. ठीक है, from x is equal to 0 to x is equal to 5. Initial point, final point. Under the influence of a force 7 minus 2x plus 3x square. अरे force is a variable. ठीक है, so question is work done. Formula for work in the case of force having a variable value. Integrate कर ले. Now the force is only along x-axis, so the displacement is only along x-axis. F dot dx I have written. From where to where? X is changing from 0 to where? हाँ 5. बिल्कुल हो गया तो हो गया, काम तो हो गया, कर ले. Now start substituting. 0 to 5. F is how much? 7 minus 2x plus 3x square. Okay, dx. Shall we start doing the integration? 7 into dx. What is the integral? 7x minus 2 x dx का integral x square by 2. Done. Plus 3 is a constant. X square का integral x cube by 3. Done. Okay. Now you have to start applying the lower limit and the upper limit. 0 to 5. Now you know that if you apply 0 to this entire quantity, वो 0 हो जाएगा. So there is no point in giving that lower limit. So start giving the upper limit. 7 into 5 minus 2 cancels. X square, x is 5 square, 25. Plus 3 into 3 is being cancelled है ना, ये 3 cancel हो जाएगा. X cube, 5 cube is 125. 125, 35 minus 25 is equal to 135 joules. बस कोई ने दे दिया? I don't think so. I don't think so. Is there anyone who have beaten me in this challenge? नहीं. I'm so happy. So this time Ameer sir is the winner. मैं तो जीत लिया, बिल्कुल जीत लिया है ना. 135 right now. Someone are giving the answer. Good. Devika, Pal, Pardeep, Myara, Prince, Sai, Myara, Varsha. Very good. It is plus, okay, not minus. ठीक है. शिशिर, okay, very good. थोड़ा मैं हिंदी में बोलूँ, ठीक है. I think after reading that I have already said हिंदी. अरे जितना मुझे आता है तो मैं उतना हिंदी में बोलने की कोशिश जरूर करूंगा, वो वादा है. ठीक है. Let us start doing one last question from yesterday's topic. Then we are going to the tomorrow's topic, which means today's topic. ठीक है, not tomorrow's topic. क्या बोल रहे हैं अमीर सर? आपका दिमाग का है ना? Next question ready है ना? बिल्कुल. Okay. By applying a force, F is equal to 3xy, अरे बाप रे, minus 5z plus 4z. You have to know that force is in the x direction, y direction and z direction. अरे बाप रे, this question थोड़ा लग जाएगा है ना. A particle is moved along the path y is equal to x square, which means the particle is moving in the xy plane. Along which line? Along this line, y equal to x square. From the point 0, 0, 0 to the point 2, 4, 0. The work done by the force on the particle. Let me write the equation for the force. Equation for force: 3xy minus 5z j cap plus 4z k cap. Now बोल दे, if the particle is moving in the xy plane, z का वैल्यू कितना है? z का वैल्यू देख ले. Initially, finally, wherever it is, if it is moving along the xy plane, z का वैल्यू कितना हो गया? जल्दी बता दे. z का वैल्यू हो गया 0, है या नहीं? और क्या सर? बिल्कुल. z का वैल्यू 0. Apply in the formula for f. So this become 3xy minus 5 into 0. 0 हो जाएगा. Then j cap is remaining. 4z, z becomes 0. So this entire term becomes 0. अरे छोटू हो गया हमारा फोर्स. फोर्स क्या हो गया? छोटू हो गया. फोर्स का इक्वेशन इज राइट नाउ f is equal to 3xy j cap, if I am not wrong. Yes, the force is given as 3xy j cap. How will you find the work done? That's a question, है ना. Integral of f dot ds. Now you already know that f is equal to 3xy j cap dot ds. मतलब the total displacement in which all direction the particle is making its motion. देख ले, it is moving along the entire x and y axis. So the total displacement will be the sum of displacement along x axis plus displacement along y axis. dx means small displacement in x, dy means छोटू सा displacement in y. बस ठीक है. So for ds I am going to write it as a sum of displacement along x, sum of displacement along y. बस हो गया तो हो गया. डॉट प्रोडक्ट कर ले. I dot j 0 हो जाएगा. j dot j is 1, so that is equal to 3xy dy integral. अरे वेरिएबल क्या है इधर का? वेरिएबल इज y, लेकिन वी हैव x एंड y इन द इंटीग्रेशन. ये नहीं कर सकता है. वी हैव टू मेक द सब्स्टिट्यूशन. कैसे? इज देयर एनीथिंग गिवन इन द क्वेश्चन? सोच ले. हाँ बिल्कुल. व्हाट इज द इक्वेशन गिवन? द पार्टिकल इज मूविंग अलोंग y इक्वल टू x स्क्वायर. y इक्वल टू x स्क्वायर. I have to substitute for this x. So x will be equal to root y or y raised to 1 by 2. Substitute कर ले फिर. Substitute कर ले in the equation. 3 x becomes y raised to half. एक और y है, dy है ना? और क्या है? This is equal to integral y raised to half plus 1, that is equal to 3 comes outside, y raised to 3 by 2 dy. Isn't it? Right. Yes sir, bilkul. And how much will this be? 3 times y raised to 3 by 2 plus 1, that is 5 by 2 divided by 5 by 2. Bilkul, itna hi hai. Okay, now you just have to start substituting the value for y. Y ka value initially it is 0 and finally the y is having a coordinate of 4. So substitute from 0 to 4. बस. So how much is this going to be? ये 2 ऊपर हो जाएगा. So this is 6 divided by 5. Y takes the upper limit of 4. 4 raised to 5 by 2. अरे 4 raised to 5 by 2 का वैल्यू क्या है? First do 4 raised to 1 by 2. Root of 4, that is 2. 2 raised to 5 है ना? So that is 32. Then multiply by 6. How much you're gonna get? You are gonna get an answer of 192 divided by 5. इतना जूस. बस ठीक है. कौन कौन लोगों को मिल गया इधर उत्तर? किसी किसी लोगों को मिल गया. म्यारा को मिल गया, देविका को मिल गया, पल, प्रदीप, वेरी गुड, बहुत बढ़िया. ओके, सो आई होप यू ऑल अंडरस्टूड दिस कॉन्सेप्ट, है ना? विद अ स्माइल बोल दे, जल्दी से जल्दी बोल दे. हाँ सर बिल्कुल. कोई गड़बड़ है तो बता. कोई डाउट नहीं है ना? Shall we move to today's concept? If you all are ready, we are going to start a new topic. अरे न्यू टॉपिक क्या है? न्यू टॉपिक क्या है? आज का टॉपिक, आज का खबर, आज का न्यू टॉपिक, कंजर्वेटिव एंड न्यू नॉन कंजर्वेटिव फोर्स. रेडी टू लर्न? रेडी है तो बोल दे, ऐसा बोल दे, गिव मी अ थम्स अप. थोड़ा आग दिखाइए मुझे. जस्ट शो मी सम फायर. जल्दी. म्यारा रेडी? ओके. Jaldi, 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 jaldi. Okay, so I think every one of you are super ready. Let's start. Now, we are going to categorize the forces as conservative forces and non-conservative forces. Based on what? Based on the work it does, or based on the kind of work it do, we are going to divide the forces into 2 types. Which are the 2 types? Conservative and non-conservative. ठीक है. Now let's see, when can we call the forces as conservative force? First we'll explain about what is a conservative force. अच्छे से सुन ले, very important, इतना important है. Now a force can be called as a conservative, right? A force can be called as a conservative force when the work done by these forces is independent of the path taken. Which means if it only depends upon the initial position and final position of the particle, okay, that kind of forces are called as conservative forces. 30% clear, Anna? I know that. Don't worry. Let's say that you are having a conservative force. Okay? You are moving a body from the point A to B in different paths. So if you are moving the body along the straight line path, let's say it is W1. and you are moving it through another path, and let's say the work is W2. And let you say that you are moving this body through another path and reaching at the point B. Let's say the work done is W3. Now, if the work done in all the cases, if it is equal, right, these kind of forces, we call it as what? Conservative forces. ऐसे फोर्स को हम बुलाते हैं कंजर्वेटिव फोर्स. लुक, you can see that the initial and final point same. So even though the path taken by the particle to reach the final position, even if it is different, right, it doesn't matter if the work done, if it is same, those kind of forces we call it as conservative forces. ठीक है? Now who is going to tell me? It depends only on the initial and final position, right? Who is going to tell me what will be the work done by this conservative forces in a closed path? Closed path means we start from a point and we end at the same point. In this closed path, what will be the work done by the conservative force? Jaldi bol de. Anyone who are listening to me, regarding the definition of conservative force will be obviously be telling. बिल्कुल बिल्कुल बढ़िया बात है आर्यन. जीरो. क्यों? Because the starting and the final point is the same, which means the displacement is zero. For conservative forces, right, it looks only on the initial and final position. So here for a closed path, initial B, final B, same point. So displacement 0. So work done in a closed path will be equal to 0 for a conservative force. Now, very good. I can see many of you have given the answer. Pardeep, Ritika, Miara, everyone. Good, good, good. Now, don't you want to know which all forces are conservative force? One of the best example is gravitational force. Bhaiya, gravitational force ko yaad hai na? It is a conservative force. Let's see whether this gravitational force is obeying all the properties of a conservative force or not. What was the first rule to be a conservative force? It should only be depending on the initial position and final position. It should be independent of the path taken for doing the work. है ना? Let's see. Let's say that I'm taking a ball of mass m. What will be the weight on this? mg. Okay. I'm taking this ball of mass m to a height of h through this path. Can you tell me what will be the work done in this case? That will be equal to force is mg. Okay, and displacement, let's say this is h as they are in the opposite direction, minus force is downward, displacement is upward, so work done is equal to minus mgh in the first case. ठीक है. Now let's see, the gravitational force depends only on the initial and final position and it is independent of the path taken. So in order to understand that, क्या कर रहा है मैं? I am going to take the ball of mass m to the same height in different path. ऐसे, 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 ऐसे and ऐसे. Let's say these heights are h1, h2 and h3. Let's start finding out the work done. Total work done is equal to, first you have to take the body from the point 1 to 2. What's the work done? Minus mgh1, force into displacement till it reaches the point 2. ठीक है. Now tell me, for taking the particle from 2 to 3, for taking the particle from 2 to 3, work done कितना है? mg. ठीक है. Displacement is in which direction? From 2 to 3 horizontal, cos theta. What is the angle? Angle बता दे. mg is downward, displacement is horizontal, mg is downward, displacement is horizontal, angle 90, cos 90, 0. मिल गया. So work done to take the particle from 2 to 3, 0 हो गया. Then let's say from 3 to 4, so it is moving upward, so minus mg h2. Why minus? mg is downward and h2 is upward. From 3 to 4, work done is minus mg h2. From 4 to 5, again work done कितना हो जाएगा? 0. Why? क्यों? Because displacement is horizontal from 4 to 5 and mg is downward. Angle is 90, so cos 90, 0 हो जाएगा. So next work done 0. Then from 5 to 6, simple, minus mg h3. Now if you take all these things minus mg outside, it will be h1 plus h2 plus h3, है ना? बिल्कुल सर बिल्कुल. What is h1 plus h2 plus h3? h1 plus h2 plus h3 क्या हो जाएगा? वो h ही हो जाएगा, है ना? बिल्कुल सर, माइनस mgh हो गया. What is minus mgh? The equation for the work done. मिल गया तो मिल गया. क्या मिल गया? We just have proved even though the path taken for taking the particle between 2 points are different, even though it is different, right, the work is going to be the same, which is a property of a conservative force. है या नहीं? है या नहीं? We just have proved. देख ले, even if you are taking straight, work done is minus mgh. Even if you are taking this curved path, minus mgh. बस हम प्रूव किया. आर यू ऑल रेडी टू ट्रस्ट मी? आर यू ऑल रेडी टू बिलीव मी? हाँ सर बिल्कुल, क्यों नहीं, आपको बिलीव ट्रस्ट करता है हम सब. सो आई होप यू ऑल हैव अंडरस्टूड दिस सिंपल सा कॉन्सेप्ट. ओके गुड. नाउ डोंट यू ऑल वांट टू ऑल्सो अंडरस्टैंड द वर्क डन बाय कंजर्वेटिव फोर्स इन अ क्लोज्ड पाथ इज जीरो, है ना? ठीक है, तो आई विल मेक यू अंडरस्टैंड. नाउ यू आर टेकिंग अ बॉल ऑफ मास m to where? To a height of h, and you are taking it back from height to backward position. Okay, let us find out the total work done, right? While moving to a height of h, work done is minus mgh. Why minus? Force is downward, displacement is upwards. From the upward, you are taking the particle down to a height of h. Now h is also downward, force is also downward. Work done is mgh with positive sign. So total work done minus mgh plus mgh. Total work done is minus mgh plus mgh. कितना कितना हो गया? जीरो हो गया. बिल्कुल, I have proved that also. Now I hope you can trust me, है ना? Now I hope you all can trust me. Those who haven't noted down, you can note it down ऐसे जल्दी से जल्दी. Atiti, yes, it is going to be zero. बिल्कुल. So there are so many various in the classroom who's so much into learning. I'm so happy for that. बहुत बढ़िया बिल्कुल. तो इधर तक कोई गड़बड़ नहीं है, अच्छे से समझ में आ गया? हंस ले थोड़ा. ओके, तो हम जा रहे हैं नेक्स्ट, नॉन कंजर्वेटिव. अरे non-conservative, if you know the properties of conservative forces, non-conservative is just the opposite, है ना? Which means in conservative, you have learned that the work done is independent of the path. So for non-conservative forces, these are the forces where the work done depends upon the path taken. Okay, the work done not only depends on the initial and the final position, it depends upon the path taken. Which means if a particle is moving from the point A to B ऐसे, okay, or in this different path, let's mark it as W1 and W2. Even though the final positions are same, the work done is not going to be same if non-conservative forces are acting on the body. Which forces? एक और बार, हाँ, non-conservative forces. The work done is dependent upon the path. It depends upon the path taken. Best example, friction. Friction भैया है best example for non-conservative forces. Okay, let's try to find out. In path 1, let us find out the work done, W1. A particle is being taken in this direction, forward. Okay, so if a particle is moving in the forward direction, friction will be opposite. Okay, let's say this is A, this is B, and this is the hypotenuse, so this will be equal to root of A square plus B square. Not a big thing, है ना? Now from point A to C, you are taking the particle. क्या किया मैं? From point A, you are taking the particle to the point C. Work done is equal to frictional force into displacement is A, from A to C. In which direction? Negative direction. Q. Force and displacement are opposite. Then for reaching the point B, you have to move from C to B. Okay, while you move from C to B also, frictional force is opposite and displacement is forward. So minus FB. minus BF. This is the work done in the first case, which means if you move along the path 1. Now देख ले, what is the work done if you move along the path 2? It is equal to, if you move in this direction, frictional force के direction हो जाएगा ऐसे, opposite to the motion. So minus F into displacement is equal to root of A square plus B square. सेम है क्या? ये दोनों सेम है क्या? अरे आंखें खुलकर देख, सेम है क्या? बिल्कुल नहीं सर. ये कैसे सेम हो सकता है? बिल्कुल, in any condition these cannot be same. है ना? So we just have proved, right, the friction totally depends upon the work done by the friction, totally depends upon the path. So it is a non-conservative force. Okay, all the resistive forces are, which means air resistance, frictional forces, you will be learning about so many other forces. Okay, so all those forces are kya forces? All those forces are non-conservative forces. Bas. Okay, now everything related to work is done. वर्क के बारे में हम पूरा का पूरा कर दिया, कुछ नहीं बाकी है. We have learned everything related to work, and we also have learned what is conservative and non-conservative forces. It's time for energy. Okay, it's trying to learn about the kinetic energy and the potential energy. आप सब लोग रेडी है? अच्छे से रेडी है? Okay, now listen. Energy, work topic is done. Energy topic. Now, what is energy? You all have that by-hearted sentence in your mind. Energy ka definition, what is that by-hearted sentence? Yeah, energy is a capacity to do work. Sir, energy is a capacity to do work. Arey, ye kya hota hai? What do you mean by that? Don't you all want to know what is the basic understanding of this? Hai na? I'll tell you. Okay, how this energy and work is actually related. Obviously they are related. I'm going to explain you in simple words. देख ले. So this is Ameer sir. ये कौन है? Ameer. मैं. Okay, so I had my food. Okay, मेरा मम्मा ने मुझे बिरयानी खिलाया. So I have so much of energy. Let's say I have some 10 joule of energy. Okay, obviously if you eat lot much of biryani, you will feel wasted after eating. You will feel so much lazy and after eating lot much of biryani. So I thought I just want to give away this 10 joule of energy from my body. What will I do? What will I do? I will start pushing this block of mass m by applying a force. So what will happen? Yes, the block will start displacing, and after moving, right, the block will be associated with a velocity. If a body is associated with a velocity, it will be associated with an energy. We call it as kinetic energy. Formula half mv square. You all know from your chotu classes, lower classes, right? Okay, so this will be getting a kinetic energy equivalent to the energy which the person was having, 10 joules. So what has happened here? Let us make a quick overview. The person was having 10 joule of energy, and he has given the 10 joule of energy to the block as the kinetic energy, which means transfer of energy has happened. How this transfer has happened, that is the important question here. How the transfer of energy has happened. How? He is applying a force and displacing the body. He is applying a force and displacing the body. Matlab, force and displacement will produce work. So the person is doing a work on that particular block, and it is that work which is taking the energy from one body to another body. Simple sa seedha sa example, right? These are two banks of a river, okay, and here you have a bridge. What is the duty of a bridge? Bridge ka duty kya hai? To take the person from one bank of the river to the other bank. Same thing is the work is also doing. Work का काम क्या है? To take the energy from one body and transfer it to another body, which means work will be receiving some energy from here. In this case, Ameer say energy it will be receiving. So how much will it be receiving in this case? 10 joules. So work will be receiving 10 joules. Okay, and that 10 joule is actually given to the body. This is the simple relationship between energy and what work done. If you have understood this basic concept, This chapter is done. और कुछ नहीं पढ़ना आप लोगों को. This is the basic concept which hold the entire chapter. We'll be learning so many work energy theorem, ye theorem, wo theorem, blah blah theorem, but everything is surrounded on this particular concept, right? The work is a carrier of energy from one body to another body. If you know this, done. ठीक है? I think I don't need to explain the kinetic energy, the energy associated with the body because of its velocity. Formula half mv square. अब सबको पता है ना? So इधर तक कोई गड़बड़ नहीं है. Have you all understood the simple concept between work and energy? जल्दी बता दे. I'll be looking into the chat box. These all simple concepts you cannot find in any of the books, NCERT, HC Verma. So if you really want to keep it in your mind, write it somewhere. This will help you a lot. These are very important things. You cannot find in any books, let me tell you that. Okay, so done. आयुष बोल रहा है यू आर सो बोरिंग सर. कौन बोल रही है आपको इधर रुकने के लिए? बोरिंग है तो आपको निकल सकता है ना? बोल दे वैरियस आयुष को, है ना? बोरिंग है तो आपको निकल सकता है. हु इज होल्डिंग यू हियर? तो इधर सब कुछ क्लियर है ना? इधर तक अच्छे वाला क्लियर, अच्छा वाला क्लियर विद अ स्माइल ऑन योर फेसेस. बिल्कुल से क्लियर है ना सब लोगों को? मेरा प्यारा वैरियस को अच्छे से. ओके, सो शैल वी डू अ स्मॉल प्रॉब्लम? छोटू सा प्रॉब्लम कर सकता है ना? बिल्कुल सर, बिल्कुल कर ले. क्लियर है ना? क्लियर. पल बोल रही है कि क्लियर है. सभी क्लियर है अर्पण. ओके, हियर वी गो. सो लेट मी सी. रेडी फॉर द कॉम्पिटिशन? कॉम्पिटिशन के लिए रेडी है ना? सो लेट मी सी हु इज गोइंग टू गिव मी द आंसर इवन बिफोर मी. सो योर चैट बॉक्स इज ऑल योर्स. आई विल बी डूइंग द क्वेश्चन फ्रॉम हियर. देख ली. छोटू क्वेश्चन है, वेरी सिंपल क्वेश्चन. द डिस्टेंस कवर्ड बाय अ बॉडी टू कम टू रेस्ट when it is moving with a speed of 2 meter per second is s. What is s? S is the displacement the body has covered, right? To move from a initial velocity of 2 meter per second, okay, to a final velocity of 0. Is there any equation to bind all these things? हाँ बिल्कुल है. Okay, v square is equal to u square plus 2s, है ना? याद है? वन डायमेंशन सबको याद है? यस, बिल्कुल सर, बिल्कुल. क्यों नहीं याद नहीं है? बिकॉज वी आर वैरियस. सब याद आता है हम लोगों को, है ना? बोल दे मुझे. सो v0, लेट्स अप्लाई दैट. v इज इक्वल टू 0 हो गया, u स्क्वायर, राइट? एंड इट इज अ रिटार्डिंग फोर्स. If force is retarding, the acceleration it produces will also be retarding. So acceleration will be negative. So 2as. So what will be the equation for s? That is u square by 2a. So the displacement the body makes before it stops is having the equation of u square by 2a. हमको equation मिल गया. Okay. Now the question, if kinetic energy double किया, अरे how to include kinetic energy here? Don't worry, we are going to include. कोई बात नहीं. If kinetic energy is doubled, which means the new kinetic energy k dash is 2 times the initial kinetic energy. If k is the initial kinetic energy, the new kinetic energy k dash is 2 times. ठीक है. The distance covered by it to come to rest for the same retarding force. If force is same, if you have doubled kinetic energy, how much will be the new value of s? Okay. Now the kinetic energy has to be included in the equation for s. कैसे करेगा? Because you know that kinetic energy का formula is half m u square. Okay, you have u square in the equation of s. So from here make an equation of u square. जल्दी कर ले. 2k by m. u square का formula हो गया 2k by m. ठीक है. Now substitute कर ले. s is equal to 2, u square equal to 2k by m. What is remaining? 2a. So 2 cancels. K by mass into acceleration. What is mass into acceleration? Force. So displacement का another formula we got in this case kinetic energy by frictional force. Now देख ले F friction force, sorry not friction force, which means retarding force, any force. Okay, the force is remaining as a constant. If kinetic energy double किया तो what will happen to displacement? इस प्लेस में कितना हो डबल हो जाएगा, डायरेक्टली रिलेटेड है. सो व्हाट बी द आंसर? 2s. k becomes 2 times, s becomes 2 times. To understand this, I don't think you need to be in 11th standard. Even a 5th standard, a 5th grader can understand. अरे छोटू प्रॉब्लम है. समझ में आ गया अच्छे से? बोल दे हाँ सर बिल्कुल अच्छे से समझ में आ गया. क्यों नहीं समझ नहीं आ सकता है ना? ओके. अरे we have another topic to learn. सर आप बोरिंग है तो कॉलेज का प्रोफेसर. आप कॉलेज पे गए क्या दीदी और ऐसे ही बोल रहे हैं? सो ठीक है, इधर तक कोई गड़बड़ नहीं है, अच्छे से समझ में आ गया. बिल्कुल सर बोल दे, बिल्कुल सर, बिल्कुल बिल्कुल बिल्कुल. So shall we move to the new part, which is potential energy? I know that once I say potential energy, the first formula which comes to your mind is mgh. Okay, mgh से काम नहीं चलेगा, which means here in this chapter. Okay, there are so many other things also to learn. So अब सब लोग रेडी है तो we can start. Okay, so here we go. पूरा का पूरा लोग रेडी है. Okay, so potential energy concept. We know that the definition given for potential energy is, right, the energy possessed by a body because of its position. Right? Velocity say to have an energy is called as kinetic energy. But how a body can have an energy because of what? Because of its position. I'll tell you, सुन ले, अच्छे से सुन ले. This is very important for understanding the concept. How a body is associated with an energy because of its position. देख ले. You are having a block of mass, which is the force associated with it. There will be a downward force of mg. If I want to lift this block, right, how much force I should be giving? A force a bit greater than mg, which means almost approximately equal to mg force you have to apply to lift up the block. ठीक है, समझ में आ गया? ठीक है. Now I am applying a force of mg on the body, and with this external force of F, you are displacing the body to a height of h. आप लोग क्या कर रहे हैं इधर? क्या कर रहा है? You are applying a force and displacing the body. So force into displacement is what? Work done. So here, for displacing a body to a height of h, you are doing a work on the body, and that work is actually stored inside the body as its potential energy. So this is the reason why a body at some particular point, at some height, is associated with a energy. We name it as potential. We name it as potential energy. Okay, क्यों? Okay, why potential energy is associated with any body? क्योंकि because for that particular body to be in that position, right, we have to apply some work. Next question. Is the potential energy at this point mgh all the time? No, we cannot tell that. We cannot assign a absolute value for potential energy. We cannot tell the potential energy is mgh here. Why it is mgh? Because we have considered the potential energy at this point as 0. Is it at a height of 0? Never. Because you have to think that this particular mass is already at some height from the center of the earth. And it is not only the earth that is present, there are other planets also. So with respect to other planet, this particular mass is having different positions. है ना? So it can have different potential energy. So absolute value of potential energy to find not possible. So what will you do? You can always find out relative value only, which means you take some random point and assign that, any point you can take potential energy, you will assign that 0. And the rest of the points are given potential energy based on this. वही है बस. This is how you define potential energy for the body. It's very important. Okay, so potential energy cannot be given a value, which means what value? Which means an absolute value. Only relative value can be given to potential energy. बहुत important. So what is the potential energy associated? The relative potential energy associated at some height. We just have proved mgh. mgh हो जाएगा. What will it be mgh? I think you already have learned. Okay. कोई गड़बड़ है तो if you can look into the figure. If you have any issues, please let me know. Super Ujjwal. Okay, good. If you don't have any doubts, we can proceed further. Proceed कर सकता है? जल्दी बता दे, जल्दी बता दे. हाँ सर, बिल्कुल आपको कर सकता है. ठीक है, तो हम जा रहे हैं अगले कॉन्सेप्ट के लिए. Now what we are going to do is, we are going to find out the relationship between the potential energy and the conservative forces. देख ले, it is very 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 important. जितना very बोल सकता हो उतना very बोल सकता है. It is super important. Okay, you have a block of mass. On this, what is the gravitational force? mg. नीचे सबको पता है. Okay, now I am taking this particular body to some height, so the potential energy associated will be equal to mgh. So this is the second position. Initially it was here, first position. What is the change in potential energy? Change in potential energy when the mass moves from the point 1 to 2, the potential energy at the point 2 mgh minus potential energy at the point 1, which we assume that it is 0. Here it is mgh. ये क्या है? डेल्टा यू क्या है? चेंज इन पोटेंशियल एनर्जी. ठीक है. ओके, नाउ keep this equation as it is there. ठीक है. Now looking back, come back everyone. Now to this block of mass m, the same block of mass m. Okay, now what is the work done by the gravitational force? क्या है? Work done by gravitational force क्या है? It is how much? mg नीचे, and as it is moving upward by h value, h with a negative sign. Why negative? mg and h are opposite, so minus mgh. The gravitational force is what kind of a force? 10 minutes before I have told you what kind of a force is gravitational force. हाँ बिल्कुल, conservative force है. Conservative force is what? The gravitational force. Now start comparing delta u, which is mgh, and work done by the gravitational force, which is a conservative force. What is the relationship you can make? If you can put a negative sign to the change in potential energy, what will you get? You will get the work done by, okay, not force, okay, I cannot equate this to force, I'm really sorry. Work done by conservative force. What is it? The negative change in potential energy is equal to work done by conservative force. This is an amazing, super amazing relationship. What is a super amazing relationship? Not the work done by entire force that we are going to learn later in work energy theorem. Here we are only have work done by conservative forces. Which are the conservative forces? Gravitational force, spring force, you learn, is equal to negative of change in potential energy. Super duper important. क्या हो गया? Super duper important. Okay, now let us proceed. Work done by conservative is equal to negative change in potential energy. Okay, what is the equation for work done by any force? F dot dx is equal to negative of change in potential energy. So if you do integrate, you will get the large change in potential energy. So if you remove this integration, F dot dx, okay, you will get the small change in potential energy. ठीक है? If you integrate, you will get the entire change in potential energy. If you remove this integration, you will get the small change in potential energy. So F conservative is equal to, if you rearrange, if this dx comes down, minus du by dx. Super duper important equation है, which means the equation to find out conservative forces, one of the conservative force, let's say gravitation, formula, the conservative force F is equal to negative of du by dx, negative of du by dx. Super important. Work done by the conservative force is equal to negative du by dx. Okay, so how can you make use of this particular equation and find it? I'll tell you. Let's say the potential energy is at a point or in a plane is given as 3, x square. What is it? Potential energy is 3x square. The question is, how will you find out the conservative force? Simple. Conservative force is equal to negative of du by dx. Negative of d by dx of u 3x square. Substitute कर ले, कर दिया सर बिल्कुल. 3 comes outside, minus 3 d by dx of x square. Anybody knows? अरे everybody should be knowing d by dx of x square कितना है? अरे 2x minus 6x. So this is the equation for conservative force. Look, if you have the equation for energy, which energy? Yes, the potential energy, right? Differentiating with a negative sign will give you the value for conservative force. बस उतना ही है. मिल गया तो मिल गया, आंसर तो मिल गया, है ना? और क्या और क्या और क्या? So shall we do a problem? प्रॉब्लम के लिए रेडी है पूरा का पूरा लोग? पूरा का पूरा लोग रेडी है क्या? You know the drill है ना in the class. Whenever a question is given, it's your responsibility to show me that values are best and better than Ameer sir. How? Give me the answer in the chat box. Done म्यारा. Very good. Pal ready? Ria. Lover cute boy. अरे इतना cute boy है. Okay, so yes, let's start doing this problem. ऐसे a particle which is constrained to move along x-axis, okay, it is only making its motion along x-axis, is subjected to a force in the same direction which varies with the distance x of the particle as, so force is given, minus kx plus ax cube is the force given, ठीक है? Here k and u नहीं a है, k and a, this a and this k are positive constants, ठीक है? For x greater than 0, the functional form of potential energy. ये कैसे करेगा? You know that, you only know that the conservative force is given as negative du by dx. Now the question is not to find the force. Force तो given है. What do you have to find? du. U value has to be found out. Potential energy कैसे? देख ले. du is equal to cross multiply f dx with a negative sign. है ना? How will you remove this small u's? If you want to find the entire u, क्या करना है? Integrate कर ले. If you integrate right hand side, left hand side भी integrate करना है. बस इतना ही है. Cross multiply, integrate, you will get the answer. Integral of du, if you integrate all small u, du मतलब छोटू u है ना? Integrate कर ले छोटू क्या हो जाएगा? You will get the bigger u. मिल गया. Now integrate from minus integral f is minus kx plus ax cube dx, bus with negative outside. Okay, what is integral of minus kx dx? Minus k x dx है, how much it is? X square by 2. This is plus a is a constant, x cube dx का integral x raised to 4 by 4. If you take the negative sign inside, a x raised to 4 by 4, right, with a negative sign, and this will become plus k x square by 2. बस उतना ही है और कुछ नहीं है. We just have to cross multiply, फिर integrate. आंसर तो ऐसे आ जाएगा, है ना? और क्या सर? बिल्कुल आ जाएगा ऐसे. तो कोई प्रॉब्लम है? कोई प्रॉब्लम नहीं है ना? एनी इश्यूज, एनी डाउट्स? इफ यू हैव, प्लीज लेट मी नो, because we are going for the new concept. Okay, so I think you don't have any doubts. I'm looking into the chat box, I can't find any. Crystal clear है ना? बढ़िया बात है. And if anyone is there who haven't liked the session अभी तक, okay, this is the right time to show how much you care and love for physics. Jaldi se jaldi you can give and click on the like button. Okay, now shall we start? Next question. ठीक है, so हम जा रहे हैं अगले question के लिए. A particle is placed at the origin. Okay, we have a particle at the origin and a force F is equal to kx. is acting on it. So force is kx acting. If u equal to 0 is 0, the graph ux versus x will be, force is given again and you have to find out the equation for u, which is potential energy. अरे which equation? That same equation we were learning, वो ये और कुछ नहीं है. So force is given, you need to find out u कैसे? Cross multiply. So du is equal to, ये negative, you can put it here, minus f dx. And total potential energy, how will you get? Integrate कर लें. So this, if you integrate du, you will get u. Negative of, f is given as kx. दे दिया है. If anyone is having doubt, देख ले. F is equal to kx, इधर given. kx dx minus k is constant, x square by 2. Okay, so the potential energy is a graph for x square with a negative sign. Okay, how is y equal to x square graph? Y equal to x square graph is like this. So here instead of y you have u, so u of x square graph ऊपर है, but here a negative sign is there, so negative x square graph will be ऐसे, है ना? ये तो ऐसे हो जाएगा. Which is this? This is the graph for what? The potential energy versus x. Which one? Option C. बस इतना ही है, देख ले. छोटू छोटू सिंपल सिंपल प्रॉब्लम है. समझ तो आ गया तो आ गया, समझ तो आ गया. आजकल ऑनलाइन में हो रहा है सेट. हाँ बिल्कुल, आजकल सारे के सारे चीज़ ऑनलाइन में ही होता है. सी इज द राइट आंसर. हाँ बिल्कुल प्रिंस, बहुत बढ़िया बहुत बढ़िया. हु ऑल हैव गिवन मी द आंसर? पल, देविका, रितिका. गुड गुड गुड, बहुत प्यारा, बहुत बड़ा, बहुत प्यारा. शैल वी प्रोसीड? नेक्स्ट क्वेश्चन. अरे बहुत सारे क्वेश्चन है आज, तो करेगा है ना? बिल्कुल सर. ओके, सो विल डू ऑल द क्वेश्चंस, है ना? डू यू वांट टू स्किप द क्वेश्चन स्किप करके नया टॉपिक लेना है क्या? क्वेश्चन से बोर हो गया तो बता दे, वी कैन गो फॉर द नेक्स्ट कॉन्सेप्ट. इफ यू वांट टू लर्न मोर, learn how to do more and more problems and understand the concepts in depth, ज़्यादा क्वेश्चन करेगा. क्वेश्चन करेगा ना? और क्या, ठीक है. तो क्वेश्चन, नेक्स्ट क्वेश्चन, जल्दी से जल्दी गिव मी द आंसर इन द चैट बॉक्स. जल्दी जल्दी जल्दी. Potential energy of a body in position A is minus 40 joule. What is it? Potential energy in position A. So UA minus 40. Work done by conservative force in moving the body from A to B is minus 20 joules. So work done by conservative force is minus 20. Find the potential energy of the body in position B. Okay, a particle is being taken from the point A to the point B. The question is, what is the potential energy at the point B? Which equation you have to use? अरे छोटू equation, work done by the conservative force, change in potential energy with the negative sign, है ना? Work done by the conservative force is negative change in potential energy. Start substituting. Work done is given, देख ले, minus 20. Minus 20 is equal to negative change in potential energy. Final potential energy minus initial. माइनस इनिशियल. यू भी अननोन है, यू है, यू ए दे दिया है minus 40. So how much it is? This minus चुक चुक कैंसिल हो जाएगा. So 20 is equal to UB plus 40. So UB कितना हो गया? 20 minus 40, वो हो गया minus 20. minus 20 क्या है? minus 20. So आंसर हो गया minus 20. कोई ने दे दिया -20. -20, आई कांट सी द आंसर. कोई नहीं दे दिया. अरे 400 दे दिया कौन? 400 कुछ नहीं है आंसर. आंसर इज -20. पल, वेरी गुड वेरी गुड. यस संचना, यस वेरी गुड. हिमांशी, ये 400 कहाँ से आ गया आपको? Even if you add, multiply this 4 other than 10, okay, you want, there is any possibility of getting 400. Okay. So next question. अगले क्वेश्चन कर ले. ओके रेडी है ना? बिल्कुल 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 तो कर ले. सो लेट्स स्टार्ट डूइंग द नेक्स्ट प्रॉब्लम. हियर वी गो एवरीवन. Work done by a conservative force in bringing a body from infinity to A is 60. What is it? Work done to take a body from infinity to A is equal to 60 joules. So work done is given. You all know that work done is equal to negative of change in potential energy. What is the change? Final potential energy minus initial. It is coming to the point A from infinity. So UA minus U infinity is equal to 60 with a negative sign. इधर तक कोई प्रॉब्लम नहीं है ना? Okay. If you want, you can take this negative sign to here. So minus 60 is equal to UA minus U infinity. Okay. Next, work done to take the same body from infinity to B is equal to 20. So what is the 20? Work done to take the body from infinity to the point B. Work done is equal to negative of change in potential energy UB minus U infinity. Right? Okay. So if you take this negative sign, let's say to the left hand side, 20 is equal to UB minus U infinity. We have the second equation also. पहला equation, second equation, फिर UB minus UA. कैसे? How will you get UB minus UA? Array, it is simple mathematics. Equation 2, okay, from equation 2 subtract the equation 1. So what will happen on the right hand side? UB minus U infinity minus UA, which means UB minus UA will come. Minus of minus plus U infinity. प्लस यू इन्फिनिटी माइनस यू इन्फिनिटी, टक टक गया, खत्म, बात ही खत्म. हम मार दिया सब लोगों को, है ना? एंड ऑन द लेफ्ट हैंड साइड ऑफ द इक्वेशन 2 minus 1 minus 20 minus 60. So this becomes 40, है ना? Which means UB minus UA का वैल्यू हो गया 40. UB minus UA का वैल्यू हो गया 40. तो आ गया ये क्वेश्चन. ठीक है, सबको आ गया. Now let us take one last question before I leave you from today's session, which is spring. Good evening, Bhumika. Myara 40, yes. Devika 40. Who all have given the answer 40? Then we have Sonam with 40, Sai with 40, then Sonam, yes, Anchana, yes, everyone. Okay, ready है ना for this last concept? एक और कॉन्सेप्ट, और कुछ नहीं. ऐसे तो कोई बात नहीं करता है, सब इग्नोर करता है. कौन इग्नोर करता है आपको? कोई नहीं. ठीक है, आप अमीर सर का क्लास है तो सबका नाम तो ऐसे ही पुकारेगा. आ गया तो आ गया, समझ तो आ गया ना? बिल्कुल बिल्कुल बिल्कुल. तो shall we learn about the spring force and the potential energy stored inside the spring force? पूरा का पूरा वैरियर्स आर्मी रेडी है? और क्या सर, बिल्कुल. I know that you all have handled a spring in your hand, है ना? I hope you all have learned or played with a spring. If spring is in its equilibrium length, which means in its own length, उसके साथ कोई force नहीं होता है. Okay, there won't be any force. But the moment you stretch the spring, let's say from this position, I am stretching the spring by a distance of x from here to here. Let's say x is there. What is x? The stretched length is called as x. So I have stretched the spring. If you stretch the spring, what your hand will be feeling? If your hand is actually stretching the spring, your hand will be actually feeling a force in the opposite direction, isn't it? Won't your hand be feeling a force in the opposite direction? The spring will be actually trying to pull your hand toward the equilibrium position. And that pulling force or that restoring force, we call it. Why restoring? That force is trying to restore the spring back to its equilibrium length, है ना? Okay, so what will that force be doing if you increase the extension? थोड़ा और extend किया तो the spring, if I extended the length of the spring, what can you observe regarding the magnitude of the force experienced by your hand? ज़्यादा हो जाएगा या कम हो जाएगा? If you extend the spring more and more, what will happen to the force experienced by your hand because of the spring? ऊपर हो जाएगा या नीचे हो जाएगा? जल्दी बता दे, जल्दी बता दे. If the extension keeps on increasing, will the restoring force or the spring force, will it be increasing or decreasing? It will be increasing. So the restoring force is directly proportional to x. What is x? X is the extended length from its equilibrium position. And you know that if it is getting displaced towards right, what is the direction of us restoring force? Restoring force ka direction will be towards opposite direction, toward the left direction. If displacement is towards right, your hand will be experiencing a pull in the opposite direction. So restoring force is opposite to displacement. Fs is directly proportional to minus x. How will you convert this into equation? Fs is equal to, multiply it with a constant, minus kx. I think we already have learned this in the chapter of laws of motion. Okay? And this k, the constant of proportionality, we call it by the name of spring constant. इसका नाम क्या है? Spring constant. Okay, it's a constant we define for the spring. बस इधर तक कोई गड़बड़ नहीं है. Now what we are going to do is, we are going to find out the potential energy stored inside the spring. Okay, how will you find out? Because you already know the equation of work done by the conservative force is equal to negative change in potential energy, है ना? Okay, spring force is a conservative force, ठीक है? And how will you find the work done? F dot dx is equal to negative of delta u. Okay, what is F? The force कितना है इधर? इधर का force कितना है? Force is equal to minus kx, है ना? So minus kx dx is equal to minus of delta u. Okay, k constant है, negative negative चुम चुम मतलब कैंसिल हो गया बस, तो k बाहर आ जाएगा. x dx का इंटेग्रल x square by 2. So change in potential energy means final minus initial. So u final minus u initial is equal to kx square by 2. What is initial matlab? What is initial matlab? Initial means when the spring was in its equilibrium length. Equilibrium length पे what will be the potential energy? Zero हो जाएगा. So potential energy will be stored inside the spring once you extend it, once there is a displacement. So if you substitute ui as 0 here, u final, which means the final potential energy, if you extend the spring by a value of x, half k x square. A spring which is extended by x will be having the potential energy having a value of half k x square. एक और बार, half k x square. Restoring force minus kx. Potential energy half kx square. याद मत कर ले. याद मत कर ले मतलब डोंट फॉरगेट. मेरा बैड हिंदी, भूलिए मत, है ना? ठीक है, जल्दी बोल दे, जल्दी बोल दे. वैरियस प्यारा वैरियस, जल्दी बोलते. ठीक है सब? ना 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 ताररम पम ना 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 ना. Sir, I have a doubt that will differentiation and integration use in this chapter. हाँ, थोड़ा थोड़ा यूज करेगा, उतना तो नहीं भूमिका, बट लेकिन हाँ जरूर यूज करेगा. तो डाउट है तो बता दे, डाउट नहीं है तो मुस्कुरा ले, गाना गाइए. ओके, बी हैप्पी. सैटरडे संडे आ रहा है. यस, सो बहुत बढ़िया. आ गया तो आ गया, समझ तो आ गया. बिल्कुल बिल्कुल बढ़िया. ओके, सॉन्ग मेरा गिटार दूसरी रूम पे है. मैं नाउ आई एम टेकिंग क्लास फ्रॉम अनदर रूम. तो मेरा सिस्टर आ गया था मेरा घर पे, तो मुझे शिफ्ट करना पड़ेगा. ओके वो मुझे किक आउट कर दिया रूम से. हाँ आपका अमीर सर को रूम भी नहीं है घर पे, तो मेरे पास गिटार नहीं है, तो कैसे कहे लाइक हाउ कैन आई सिंग द सॉन्ग. सॉरी. तो कोई गड़बड़ नहीं है. आई थिंक एवरीथिंग इज क्लियर. सो व्हाट यू ऑल हैव टू डू, this is the time for every one of you to show some love towards physics and Ameer sir and for everything whatever we are doing here, है ना. So for every educators it will be an amazing thing if you give some compliments and if you give some motivation. How? Just click on the like button and tell them how much you love physics and how much you are loving that thing, the teachers, and that innovation that being taken by the teachers to take the classes. Okay, we are done for the day, Ritika. Okay, आज का क्लास खत्म. So I think no doubts are there. So क्या करना है आप लोगों को, before you come to tomorrow's class, please do study all these topics, super important. And tomorrow we are going to start with a new topic which is work for energy. Work for energy we will be starting in tomorrow's session. Amazing questions we are going to see. It is going to be super important session for tomorrow. So jaldi se jaldi everyone please do come. Not tomorrow, which means Monday. Our classes from Monday to Friday. Monday to Friday at 8 p.m. okay, for 11th standard. So Monday we'll be having the third session and we'll be starting with the new topic of work energy theorem. So everyone please do come to the class. It is so much important. ठीक है. So I think it's time to say bye bye. We all will be meeting on Monday 8 p.m. So bye everyone. Okay, so take care. We all will be meeting in the next class. And before saying bye bye, I just want to say don't forget to like the class. Okay, and please do subscribe to the channel so that you won't miss any notification. And let me remind you again, this is one of the time which you should be coming for and taking the plus and iconic subscription. Why? Because if you start now, you can complete the entire syllabus and you can prepare in the best way possible and get a very good marks for your upcoming board, JEE or NEET. And if you make the subscription right now before 13th of September, you'll be getting 4 months free for a 12-month subscription, and for 24-month subscription extra 6 months free. Okay, so make use of it. And you also always know I am there with you all to give you an extra 10% of discount, है ना. क्या करना है, when they ask you the referral code, use this AMB10. Okay, so don't forget all these things. use करने के लिए भूलिए मत. And yes, we all are going to be meeting in next session. So bye everyone, take care and have an amazing weekend.